Colby, math.com.
Okay, we've been practicing with integer exponents and then using integer exponents with base 10 to convert numbers to and from scientific notation. In this problem number 3, we have a base number of 4, positive 4, with an exponent of negative 3. And these are the toughest problems when you have a negative integer exponent. But the way you deal with it is you get rid of the negative integer by taking the reciprocal of the base number. The reciprocal of 4 is 1/4. And we looked at patterns in class to understand why that was true. You can also refer to, the decimal, the digits after the decimal in base 10, tenths, hundredths, thousandths, to understand that that's what's always going on with negative integer exponents. And so if we change the base number to its reciprocal, we can then take the opposite exponent, which in this case would be the opposite of negative 3 or positive 3. It's just easier to deal with the positive exponent, because then we can treat this like any other number to the third power and just realizing that we're multiplying that base number 3 times. A fourth multiplied by a fourth multiplied by 1/4. 1/4 multiplied by 1/4 is 1/16. And a 16th multiplied by a fourth, our numerator will be 1. 1 multiplied by 1 is 1. And 16 multiplied by 4 is 64. And so 4 to the negative third power does not give you a negative number. That's another misunderstanding about negative integer exponents. It just tells you that you're taking the reciprocal of the base number, cubed in this case. So 1/64 would be the correct answer for number 3. On problem number 14, we're going from scientific notation to standard form. And so scientific notation is always an expression showing the product of two factors, one of which is greater than or equal to 1 and less than 10, and the other of which is a power of 10. So in this case, 10 to the negative fifth power. You should take your first factor, your 8.1 in this case, and decide which way you need to move the decimal. This is very much like converting metric units. So if you think about this other factor, you realize that this expression is expressing a number that is very small, and so we need to move our decimal to the left in this case. Every 10 to the negative 1 is 1/10, and multiplying by a tenth is the same as dividing by 10. So we're going to move the decimal 5 places to the left. So you should rewrite this number big somewhere off to the side, and then you should move that decimal 1, 2, 3, 4, 5 to the left, and where it lands, make a very big decimal to remind yourself now it's here, it's no longer where it started. If you make your jumps very pronounced and large like this, then you can fill them in just like you fill in an egg carton. Each 0 is like an egg sitting in the egg carton. And so we have, when we rewrite our answer, we have 0.000081. That's 81 ending in the millionths place, so that's 81 millionths. And it's a good habit to get in to put this, it's called the leading 0, the 0 in the ones place or the units digit. It's not required. It would be correct if you didn't have that, but it's just good practice, especially for things you'll do in science, to include that leading 0. So that's the solution to 14. 25 I'm going to have you mostly do on your own after the pause, but I'm just going to remind you before you start that in order for this to be written in scientific notation, we need this decimal in a place where our first factor is greater than or equal to 1, but less than 10. If I just move it to here, I would have 0.94. That is not greater than or equal to 1. That's less than 1. You need your decimal here so that you have 9.4, 9 4/10 as the first factor, because that's greater than or equal to 1 and less than 10. So try to use your notes and convert that one during the pause, and then come back and see how you did.
Paused.
Using the method we practiced in class, you would first rewrite the number. You don't want to do this, you don't want to make these jumps on the original number because you want to be able to look back at the original problem in case you make a mistake. You don't want to clutter it up. So rewrite it, and then think about where that decimal needs to be. It needs to be here in order for that first factor to be greater than or equal to 1 but less than 10. So put it where it needs to go, and then think about how you would need to move it to get it back to the actual value. You would need to move it 1, 2, 3, 4, 5 to the left. So 5 to the left would be 10 to the negative 5th power. So you have 9.4 times 10 to the negative 5th power. Another way to make sure you get your exponent right is just think about, was the number a big number or a small number when we started? It was a very small number. It was much, much less than 1. And so this power of 10 is going to have a negative exponent. One thing you can do to be very thorough is then take your answer and convert it back by moving the decimal 1, 2, 3, 4, 5, and filling in those jumps with zeros to see if you get what you started with, which of course we do. I hope that helped with the assignment. I'll see you tomorrow.